Hello everyone. In this class of data analysis, we will be covering the first topic from Unit 1 written by Levine et al. This is from the book Statistics for Managers using Microsoft Excel. The topic is called First Things First, and in this, the author tries to make you think differently about statistics. But how do they do this? They do this by highlighting the business analytics or the use cases of statistics in business analytics and how that is changing the face of statistics. We also see how to learn statistics differently in a way that not only is it more enjoyable but also gives us better skills to apply statistics in business scenarios, in research cases, in data analysis, and make it more helpful for us. The author starts with a very nice example about using statistics and how use of statistics has changed over the last century. So the author takes the example of a theatrical production in 1900s where the author highlights that the use of statistics is limited. Why? Because in 1900s we did not have any computers and the capabilities of statistics could not be utilized fully because of lack of computing power. Now, if in 1900s you have a theatrical production, you run a theatrical production, then after you firstly set a price for the show, and after the show gets over, you sit with the collections you have, the revenue collections you have from the show, and analyze if you could have had a better strategy to earn more money through the show, depending on if it went full house or if there were vacant seats in the show. But by 1970s, usage of computers started in most business areas and the power of statistics could be applied. So as we proceed through 1970s and in later decades, the managers could utilize the summary reports of advance sales. So now sales can be booked in advance. You get summary reports of advance sales and you can analyze those advance sales using statistics and devise a newer strategy to earn more money. And if we talk about today, the current use of statistics is even larger. If we book a show today, then using applications, say the Book My Show application, particular seats can be booked. Real time information goes to the app owners that which seats are vacant, which are booked, and they can, in that manner, run analysis and send offers to individual clients, individual customers, so that each house can be fully booked. Each theatrical production gets fully, each run of the theatrical production gets fully booked. The author now presents a case study. In this case study, the author takes the example of the Lion King show running on Broadway in 2014. And in that year, it was realized that in 2013, the highest grossing show on Broadway was the Lion King being run by Disney. Now, Lion King was a 17-year-old show. It had been running from late 1990s, and it was a old show. Tickets for old show usually sell less than newer shows. It was also less expensive. The most expensive ticket of the Lion Show was less expensive than the most expensive tickets of other shows. So the cap to which you can earn from each seat has also reduced. It was also a long show, so lesser runs of this show can be done in a particular day. But despite all these limitations, it was seen that The Lion King becomes the top grossing show on Broadway in 2013. Now, how did this happen? This happened because Disney used statistics, they used data analysis, they used their business acumen to increase their revenue from this old show, this long running show. They collected data daily. Summaries and analysis were done using those data, and with application of business acumen, they developed a new interactive seating map where different pricing was set for each seat. They also invested in heavier advertising, but still, the new interactive seating map and the different pricing, which had been decided using data analysis, helped them to increase the revenue from this show. The author now presents his case or their case for thinking differently about statistics. There is a very old quote by Mark Twain about statistics that there are lies, damned lies, and statistics. Statistics gets a very bad light because of a wrong usage of statistics. The author highlights that this is not the problem of the tool, but the misuse of the tool being statistical methods. First of all, this is used sometimes as a substitution of decision making process, whereas statistics is uh, designed to be used not as a substitution for decision making process, rather to help with the decision making process, to enhance the decision making process. Second is the mistake that is done using statistics is not following a proper framework. The author highlights that there is a DCOVA framework to avoid errors in running a statistical analysis. By DCOVA, we mean from D, define, from C, collect, from O, organize, from V, visualize, and A, analyze. Each of these steps have to be run in this particular order. First, looking at the business problem, we define the variables that we need. We understand the business problem, then we think of the variables that will be needed for us to run a statistical analysis in order to resolve that problem. So we define the variables. Then, as per the definition of the variables, we collect data for those variables. We organize the data in a way that it fits the process, the analysis process that we have to follow. We visualize it, and then we begin the analysis part. In this book, there is a software used, which is Microsoft Excel. Why are we giving preference for software? Why not rely on manual calculations? Firstly, the softwares help us to calculate faster. They are more accurate in their calculations. Manually, errors can be made, but using software, we can minimize the errors. And thirdly, businesses can build worksheet solutions or templates. What is this? Say we have to run a average function each month. For a particular variable, we have to calculate averages. Now, in a particular Excel sheet, we can keep this formula saved, and each time the new data comes, we can feed the data in the same template, same Excel worksheet. The worksheet will automatically calculate the newer number and give it to us. Firstly, this reduces effort. An average function is a very simple example, but companies run many functions, many calculations, sometimes very difficult and complex calculations as well. So, saving a particular calculation, a particular function which is correct, helps in reducing the effort on of building that function again. And secondly, it reduces the errors. Suppose if we were not keeping these templates, then each month we would have to build the function from scratch, the same function from scratch. A minor error in building that function may lead to totally different results and answers, and it introduces errors. Now we come to business analytics. Business analytics is using statistics, amongst other things, to solve business problems. Let us see what this means in detail. Business analytics is a combination of statistical methods, information systems, and management science. Statistical methods are the part where you analyze and explore data. Information systems are where you are collecting and processing data. And management science is helping you develop optimization models on the results of information systems and statistical methods. These optimization models then help the managers from handling daily operations in the most efficient manner to strategic planning in the future. Another term that is very common in data analysis is big data. Big data has become very famous in the corporate field, and there are specific jobs, and it has in itself become a field, a career path. But what is big data? Big data is data that is being collected in huge volumes at very fast rates. Moreover, it can't even be browsed or analyzed using traditional methods. Newer ways have had to be developed in the past to handle and analyze this big data. It is stored in various forms. It can be stored in the form of files, tables, worksheets, picture format, etc. And Information systems and statistical methods both help us to combine and summarize this big data. The author then moves on to explaining what is structured and unstructured data. A structured data is the one which exists in repeating records in rows which are of similar format. This can be, usually we record this in worksheet files. For instance, take the example of GDP. GDP growth rates are recorded in percentages. Now, World Bank database offers us GDP data, growth rate, growth rate of GDP data across years for all the countries. We can download that data in worksheet files and a similar format in the sense that each cell will be in percentage terms. Growth rate is measured in percentage, so each cell of each country across the years will be in percentage terms, giving us how much growth of GDP happened in that year for that particular country. So that becomes a structured data, repeating records, and they are in similar format. What is unstructured data then? Unstructured data is the one which is following very little or no repeating internal structure. The example could be, say a political party is seeing a particular social issue, and it has to it and there's a controversy regarding that social issue. Now it has to announce its stance on that issue. Does it is it in support or against? So it can go to social media, say Twitter, and it can look at the various tweets of people, of the general public of that country, before announcing its stance on that issue. These tweets can be in the text format, or these can be in the form of memes that are posted by people ridiculing something. So the party could look at the tweets. Those tweets become unstructured data. They can be in text format, in picture format, etc. The author then moves to learning statistics. What is the best way to learn statistics? The author says that the best way is to learn the definitions and explanations of various topics in statistics. But it should also be accompanied with many examples, because only the examples can make the topic, make the subject relatable, as well as these examples help you to retain the knowledge, the subject for a very long time. The author presents three definitions to start with. Firstly, what is a variable? A variable defines a characteristic or a property of an item or an individual, and it varies. These characteristics or properties, they vary among the occurrences of those items or individuals. For instance, we have talked about GDP data. GDP data for each country becomes a variable. It is varying for that particular country across the years. So it is showing a characteristic about a particular country, and it is also varying among the occurrences. We are using the word data again and again, but what is the precise definition of data? Data, by data we mean set of values associated with one or more variables. So again, taking the example of GDP, if we say that for 190 countries, we take the GDP numbers across, say, the years 2011 to 2021. In that case, GDP data becomes the set of values of GDP of all those countries across all those years. But we can also restrict the data. Data would also be GDP values for a single country for 2011 to 2021. So set of values associated with one or more variables. We have been studying and talking about statistics throughout this lecture. We haven't still defined statistics precisely. Statistics, it refers to the methods that we apply to analyze the data of the variable of interest. We can even apply these to multiple variables, and mostly to solve any business problem, you have to apply these methods to multiple variables. That is statistics. We end this lecture here and we will start with chapter 1 of Levine in the next lecture.